As we're going down, you'll notice there's a rock fall net. This was put up for construction purposes, and that'll stay up. So to protect vehicles and workers, you'll see some rocks have fallen over time, but the net captures those. And on this guardrail to our left, it might be hard to see, but once, as one of the last items of construction, we're going to install elevation markers on poles. These will be mounted on the guardrail, and then on top of the pole will be signed with the elevation mark shown 200 feet or 100 feet. And what that'll give us the ability to do is when we're at the top surface of the reservoir and the reservoir is filled, we'll be able to look down and see what elevation the water is in the reservoir. So this access ramp is a stone ramp, and as part of the original contract we were going to pave this, but as we talked about it some more, we decided to keep it unpaved, and the reason is once the reservoir goes live, it would be hard to come in and do maintenance on the ramp. With the freeze-thaw cycle in Chicago, possible cracks may develop over time, but how would you come in at some point and repave it and maintain it? So we'll keep it as a stone ramp and measure how well this works in the future. So the reservoir construction was broken up into 3 different contracts. One contract dealt with sealing the perimeter of the reservoir. Another contract dealt with the connection tunnel and the wheel gates that regulate how much flow comes into the reservoir. And then the third contract dealt with the final preparation of the reservoir. We'll talk about that in a little bit. But the first contract dealt with the sealing off, and one of the components of that was creating a grout curtain around the perimeter of the reservoir. And how we did that was at the surface, around the entire 2-mile perimeter of the reservoir, we drilled holes every 5 feet.
Your ears popping?
And we drilled those down 500 feet deep into the shale bedrock below the reservoir. And in each of those holes, we filled it in with pressurized grouts in stages. As that grout filled up each hole, as the grout filled up the holes, it also migrated into fissures and cracks in between the directionally bored holes. So essentially we created an impervious or impermeable barrier around the entire reservoir. And what that does is when the reservoir fills up, it'll keep the water, the polluted water, from migrating out into the adjacent groundwater. And likewise, the adjacent groundwater won't be able to migrate into the reservoir. So we did that once around the perimeter, and we actually doubled it up. We did it twice. So there are 2 grout curtains around the entire 2-mile perimeter of the reservoir. So we're making our way down. We're almost at negative 300 elevation right now. For stability purposes, if you look over, you can see there are 2 shelves on the south side of the reservoir. There's a middle shelf and then a lower shelf. And those help hold back the rock dam that extends underneath the tollway. You can also see there are 2 little caves, it looks like, one at the very bottom of the reservoir and then one in the middle shelf. And what those are haul tunnels. Those actually provided access over to the quarry on the south side of the expressway, which is still active, still being mined. However, those have now been sealed off. So there's a concrete, reinforced, structurally with rebar bulkhead in each of those, about 100 feet back. And those will seal off the quarry on the south side and not let any of the polluted stormwater from the Thornton Reservoir migrate to the south. Also, you can see the rock dam, the roller compacted concrete dam up at the top. We'll look at that a little bit later. It's one of the largest dams in the state of Illinois. So we're at the bottom of the reservoir, and as we move up here to the left, we'll see the first connection tunnel. And it was an exciting week here as there was a lot of concrete being poured to finish this one off, and I believe they're finished now, but as we look at it, we'll know for sure. I haven't been down here since last Sunday. So this tunnel is the connection tunnel to the Calumet tarp system. This tunnel runs about 1,300 feet until it connects to the active live deep tunnel that's part of the Calumet tarp system. Right now there is a concrete bulkhead in place. So the last step we'll have to make before we make the reservoir live is to saw cut and jackhammer out this rock plug or this concrete bulkhead that's in place. Once that's removed, the tarp system or the deep tunnel for the Calumet system will be connected to our Thornton Reservoir, and flows will be able to enter. Now, interestingly enough, in front of the portal hole, and again, this is a 30-foot diameter connection tunnel, there is essentially what is a giant splash pad. This is a concrete pad, and the reason for this is the flows, once the system is active, will be coming out of this tunnel at great velocities of 30 feet per second. So without this splash pad or diffuser pad, what would happen is those flows would erode the bottom of the reservoir away or scour the bottom. So this splash pad's going to keep the bottom of the reservoir in place. Now it looks like the concrete has mostly been poured. Last week when we came down we saw exposed rebar, but they were pumping out the excavation as this pad is 4 feet thick. But it looks like they finished. Now this will cure in place for a while and it will be established. So inside the connection tunnel, as it goes towards the Calumet deep tunnel system, it goes 1,000 feet and then splits into 2 different tunnels. It goes from a 30-foot diameter tunnel to 2 square tunnels, or actually rectangular tunnels. And in each of those tunnels, there are 2 wheel gates. And those gates are 100 tons in weight apiece. There's a main gate and then there's a backup gate. So those gates will come down and they'll go back up depending on what the flows are and how much water is being sent into the reservoir. The gates are designed to withstand 300 feet of pressure head on either side. So they're huge, massive engineered items. They're 29 feet tall, 15 feet wide, 4 feet thick each. So you can imagine they're engineered to withstand incredible forces. So as the reservoir fills up, those gates, which were left open at the beginning of the storm, will come down eventually as the reservoir fills to the top, and then once the storm event passes, we'll slowly raise the gates back up and let the water flow back into the Calumet tunnel system, where it will be pumped back to the Calumet Water Reclamation Plant at 130th and the Bishop Ford. The water will be treated there, and then it will be sent on its way. So as we move on, we'll look at the next tunnel. Now there are 2 tunnels coming into the reservoir. We looked at the tunnel here at the northeast corner, and there's a tunnel at the southeast corner as well. And the southeast tunnel goes towards Thorn Creek. So this tunnel on the southeast side, it's a little bit smaller in diameter. It's 20-foot diameter versus 30-foot diameter. And we'll have a diffuser pad or a splash pad in front of this one as well. However, the progress on this splash pad hasn't quite made it the same. We haven't made quite the same amount of progress on this one. So we'll be online, and I'll answer any questions at the end. I appreciate the question though. So we'll talk about this. We're going online in the middle of August, tentatively August 15th. So there's only a couple steps left to finish before we go online. Once we're online, this will accept water, and we won't be doing any more tours for sure at the bottom. So the connection tunnel over here, you can see we've excavated it a bit. It's a little bit wet over there, but we still have to pour that pad. Now you can see, if you look back over to your left, the walls appear to be wet. And the reason for that is at the very top, there's a culvert that comes underneath the tollway. So there's a lot of flow during rain events that comes over this corner of the reservoir and flows down the shelves. You'll also see that same effect at the southwest corner as well. Here you can see a really good picture of a really good view of the roller compacted concrete dam that's in place. Now that was established on top of a haul tunnel that used to go over to the south quarry. So that dam is 116 feet tall. It's 84 feet wide at the base and about 22 feet wide at the top. It's one of the largest dams in the world, in the state of Illinois. There's a dam larger than that, I believe, in Lake Shelbyville, but this is one of the largest ones in the state. So that cuts off the reservoir in addition to the two bulkheads we talked about in the Hall Tunnel, that separates the reservoir from the active mine over on the south side of the expressway. Now, at the bottom of the reservoir, we'll always maintain a 10-foot maintenance pool. So there will always be about 10 feet of standing water at the bottom of the reservoir, and the reason for that is twofold. First, you have to remember what's coming into the reservoir will include a lot of solids. I mean, it's going to be storm water, but it also will be polluted sewage water. So that maintenance pool will allow the solids to settle out to the bottom. And then once every 5 years, the district will come in and de-water the reservoir and take those solids out of here and then probably take them to our LASMA facility at LaGrange Road and the Stevenson Expressway. But also, the maintenance pool will also control odors. By having the solids underwater, the odors will be mitigated, if not minimized, or totally eliminated. Also, on top of the maintenance pool, we've designed a surface aeration system with 7 surface aerators that will work by solar power. So those aerators will keep the top 5 feet of the maintenance pool from going septic. They'll oxidize that water, and the odors will be minimized, if not completely eliminated. Those surface aerators will float up and down on top of the water surface of the reservoir as it flows up and down. So we'll move on. It's interesting that you think about the origin of the reservoir and the reason it's here, and really it dates back to the beginning of development in the city of Chicago. When the city was built and also the inner ring suburbs, there was only one sewer system, a combined sewer. So all of the domestic flow that comes from your homes and from businesses goes into the same sewer system as the rainfall that falls in the streets. So a long time ago, that wasn't an issue. We had plenty of capacity, but as population growth occurred and the city was built out and the inner ring suburbs developed, we saw more people, so there was more domestic flow going into the sewer and also more impervious areas, so less water from rain was actually infiltrating into the ground. It was going to the sewer system. So in dry weather conditions, it wasn't an issue, but during rainfall events, moderate rainfall events, the heavy rainfall events, those sewers would fill to capacity very quickly. So we had to close the gates to our treatment plants, and that water had nowhere to go, so it would overflow into the, what was that? We hit a little bit of a rock.
Okay.
So that water would overflow into our waterways, into the Chicago River, into the Des Moines River, and that's why our rivers became so polluted about 50 or 60 years ago. So with Deep Tunnel coming online, and the first construction of Deep Tunnel started in 1975, the tunnel first opened in 1985, and construction on Deep Tunnel ended in 2006. And so it took about